Hello guys, today we are going to talk about the slope-intercept form of a linear equation, which is actually one of my favorite forms. It is the most common way that you'll see a line written where you have two variables, y and x, representing your locations on the graph. So what you'll see is the slope-intercept form is, in itself, just the y equals mx plus b form, where m is the slope. And actually that can also be represented by, in our last lesson we talked about the k, so sometimes that will be our k. And then b is the y-intercept, or where our line starts or intersects the y-axis. And always remember that our vertical axis is our y-axis. So if we look here then in our part A, got it, we have y equals -1/2 x plus 2/3. We want to talk about what's the slope and what's the y-intercept. So we could say that the slope of this line here, well, slope is always found by the coefficient, or the value that is multiplied by our x variable. So that actually is a -1/2. And our y-intercept, which I often abbreviate y-int, that is then the constant value added or subtracted. Here it's added, so that then makes my y-intercept 2/3. So this is when we get into quick graphs of the equation. So now that I know my slope and my y-intercept, I can think about what the graph would be. So my y-intercept happening at 2/3 means I will have a point, and this is hard on my smart pad, but I'll have a point at 2/3 where my line intersects the y-axis, and my slope is -1/2. So that means that every time, remember this is rise over run, so let's relabel that here. This is our rise and our denominator is our run. So because it's negative, that means I will go down 1 as I go over 2. And I like to just go the entire block. So say you were using graph paper for this, you go down an entire 1, which means now we'd be at -1/3. But then we'd have to go over 2, and then I can connect these, and that is relatively how my line would look, and it would extend the other way also. My slope is slightly off there because my smart pad, but that's a relative sketch. So then this asks me, what would happen if my y-intercept was moved down by 3? Well, that shifted some things weird right there. But so if I moved my y-intercept down by 3, that would be this value right here, 2/3. Well, if it would go down by 3, let's use green to represent this new line. Well, if I decrease my y-intercept, so 2/3 minus 3 would be -2 1/3. But now, did my slope change? No, it said nothing about the slope. So all that means is I'd be at -2 1/3, probably somewhere down here, with the same line slope. It would just be in a different location. So all it would change if my y-intercept was moved is the location of the line, or where the line intersects the y-axis. The slope would stay the same. So these two lines should actually be parallel. It doesn't look very good on here, but that's what you're looking for. So now go ahead and try to write this equation, which means pause the video and put it into y equals mx plus b form. So I like to start by writing out y equals mx plus b and then replacing what values I know with the numbers I know. So pause the video now and try to do that. When you plug in your values, we don't know a y. What we do know is a slope of 3/2 and a y-intercept of -1. Now, a big mistake will be they try to plug in the y-intercept in for the y. That y actually is part of a point on the line. So instead, we just plug in the slope for our m value. So that becomes 3/2 x. And then our y-intercept is -1. So we can either put plus a -1, or I could rewrite this as y equals 3/2 x minus 1. One thing that we want to be able to do is when we look at a line of a graph, we want to be able to quickly make a couple determinations about it. So the first thing to do when you're looking at a graph is always check your scaling. Here every box is worth 1, both horizontally and vertically, so that's good. So then the first thing to think about is there a y-intercept that we can find? And then what about the slope? Now this question here is specifically asking about what do you know about the slope. Well, since going left to right, it is going down, what do you think about the slope? Is it going to be positive? Is it going to be negative? Will it be 0? Will it be undefined? So actually our slope here, you should be thinking, will be some kind of negative value. And we can actually figure that out by doing our rise over run, or making that right triangle from a lesson or two ago. If I make that right triangle, my rise is a -1, my run is a +1. So since it's -1 over 1, we just get -1 as my slope. Now my y-intercept, just where my line crosses the axis, well, that is at the point of 2. So then if I want to write the equation, go ahead, pause the video for a second, write your equation in the y equals mx plus b form. So that is y equals m, again, is our slope. So here that's a -1. And then our y-intercept is 2. Now I can rewrite this again, because instead of putting -1, I can just put -x plus 2. Alright, take a moment and write out the equation for both of these lines. You want to find out the slope by doing the rise over run method. So go from one point to another point, or, I mean, there's a lot of different choices that you can make for point to point here. And then find out your y-intercept and write the equations for these lines. So pause the video now. Alright, so we know that to find slope, that's rise over run. So on our first graph here, we can set up that m, our slope, is going to be rise over run, which we can find a couple different ways. We can actually, any point to point, so I can do the little guy right here, little triangle that we make, and that gives me -1 over 2, because my rise was -1, my run was 2. I can go a wider point to point, from way out here to way over here, and that's a -3 over 6. My rise was -3, my run was 6. Either way, that gives me a slope value of -1/2. Now the only other thing that we need to figure out is our y-intercept. And that, just counting up, 1, 2, 3 is where that falls. So then to create my equation, my slope goes in for my m, and my y-intercept is the last thing. It's just the constant added on. If you did not do 6 yet, stop and do that. So here we look at our y-intercept, and whichever you do first doesn't really matter. My y-intercept is right there. It is actually a value of -2. So then that is one of the points that I can use for finding my slope. So then I go to another point, and there is actually my next point. So I do my rise and my my rise is 3, my run is 2, so that gives me a slope of 3 over 2. Sorry about that. So our slope is 3 over 2, our y-intercept is -2, which then when I write out the equation of this line, I get y equals 3/2 x minus 2. If I go ahead and simplify. Now I could have written plus a -2, but it's easier to just go ahead and put the minus there. Alright, now we already talked slightly about this in one of the previous video lessons, so take a second and try to figure out the slope of this line. You have 2 points here, so we can do a point-to-point method. And remember that our slope is always the change in y over the change in x. So another way that we can write out slope is our delta y over delta x. So pause the video for a second, try to figure that out. So we can identify that we want delta y over delta x, but what delta means again is change in. So we can find change by doing a difference or a subtraction. So y2 minus y1, my y values are this -3 and that -2. My x2 minus x1, those values are 1 and 3. So go ahead and try to fill that in. And remember, we talk about this first point as my x1, y1, and the second point as my x2, y2. Alright, so we want to go ahead and plug in our y2 is -3, our y1 is -2, so make sure that you have that minus a negative here, which those will combine and make addition. And then we have x2 is 1 and x1 is 3, so we do x2 minus x1. So now we really have on top -3 plus 2, and on bottom we really have 1 minus 3. Well, we can figure these out fairly easily. -3 plus 2, -1. 1 minus 3 is -2. And when we have a negative divided by a negative, they cancel out, so we get a slope of 1/2. Now, the question becomes, how do I write this in slope-intercept form? The one thing that I still don't know anything about is where does this line intercept with the y-axis? Well, that is actually fairly easy to figure out now that we know our slope and that we know a point. So since we know that this is our m value, we can take either of these points to be my x and my y. So you want to start by setting up the y equals mx plus b equation, and then we're going to fill in what we know. And we have a choice here because my slope is 1/2, so that's 1/2 x plus b, but now I can go ahead and fill in one of these points. So it's up to you to choose. Now I always like when there's a 1 involved. That makes my life really easy. So I'm going to go ahead and use this second point here, the 1 and the -3. So I will plug in the -3 for a y. My slope is still the same. My x is now that +1. And we still don't know the y-intercept, but what's convenient is that's the only thing we don't know now. So I'm going to scroll to give myself a little bit extra, and I need to fix that equal sign. So now we have -3 is equal, well, 1/2 times 1 is just 1/2 plus b. To get rid of this +1/2 from over here, we want to subtract that from both sides. So now what I see there is -3.5 is equal to b. So when I go to write that equation in the full slope-intercept form, it will be that y is equal to my original slope of 1/2 x plus the y-intercept of -3.5, which again I could rewrite as just y equals 1/2 x minus 3.5. And there you have it. So now moving on down the page, go ahead and try 7 and 8 on your own. I just showed you how to do it with one of them. You want to first start by finding your slope. Then once you have your slope, plug things in. So again, to review the process really quick, we start by finding your slope. Do y2 minus y1, x2 minus x1. Do that division, find out what the slope is. Set up your equation using that slope, then plug in a point. I chose this second point here, plugged in down here. Plug in the y for the y, the x for the x. Find out what your y-intercept is, and then rewrite the equation with y and x just as variables. So try 7 and 8, pause the video now. Alright, your process should start by looking something like this, where you have your delta y over delta x. We do y2 minus y1, x2 minus x1, and I get a slope of -1. If you do not have that, you want to check your math and see what you've done. When we set up this equation and plug in our x and our y, I chose this second point again. So -1 was my y, 3 was my x. So now I have -1, I'm changing colors here, equals -3 plus b. So now on both sides, to get the b by itself, because all I have over here is a -3 attached with arithmetic, I use arithmetic to undo it. So I just add 3 to both sides. -1 plus 3. So now that we see that b is equal to 2, I can set up my whole equation by saying that it is y equal to my original slope was -1. So I can just say -x plus my b of 2. I'm running out of time, so try 8. I will pop back on here with only the solution. So please pause the video now, try it on your own. Alright, so here we have the whole solution done out. I found my slope to be -1/4 by the change in y over the change in x. I plug that into my equation, then I choose an x and a y. Again, I use my second point. My y was 2, my x was 1. I solve out the math and I find that my y-intercept was 2 1/4, and then I set up my equation right here in the y equals mx plus b form. So on these problems, we're going to need to graph these lines, and we know the slope and we know the y-intercept for both of them, but make sure that you pay attention over here especially. We need a y-intercept of -8, so when you draw your x and your y axes on here, leave space for that. So go ahead and do that right now. Alright, poorly drawn, but again, I'm still getting used to my smart slate. So you want to identify your y-intercept first. It's always easiest to look at your y-intercepts first. So my y-intercept here is +4, my y-intercept over here is -8. So over here on my left graph, if my slope is -3, then thinking about that as rise over run, I can say it's -3 over 1, so I can go down by 3, over by 1. I could do that again, but I'd actually be off the graph, or I can actually do the opposite, because I can write -3 as +3 over -1, so I could go up 3 over left 1. Either way, those will all connect into one straight line. So do the same thing on this graph to plot your points and make your line. Again, it's really hard for me to draw a straight line on this tablet, but this is relatively what your graph should look like. Probably a little bit cleaner than mine, but that is it. So please let me know if you have any questions, comments, or concerns about this topic. Otherwise, do the 3-3 homework, and I will see you